I was starting to tell you about the different types of OCR, right? And I was describing a document-centric one, the more classic OCR. And from the name you can guess, but it's usually used with the paper documents for the cases like digitalizing documents, making scanned PDF searchable, processing invoices, receipts, and reports, and one type just from me, it's the scanning text and pre-filling web forms, or just a retrieval of some crucial information you can gather from the documents. A scene or real-world OCR, it's a more modern type, which also requires more modern solutions, more powerful tools to work with, because the images or frames that needs to be scanned in this group are much more complicated than just a regular photo of the document. We are talking about pictures of signs, of license plates, product labels, and so on. Such pictures are much harder to read because they usually include much more background noise, some different angles and lighting and so on. So the usual use cases, like I mentioned, are reading of the license plates, street signage, variety of translation tools, as well as the tools that I mentioned for visually impaired people with the text reading. So the four main steps of OCR, or the process of it, and the first one is always image pre-processing. At this point, the system didn't yet receive the image. At this point, we are doing manually, or the tool doing itself, the different types of enhancements and steps to make image as much more readable as it possible, to make OCR result better. It can include different types of work with the scaling of the image. You can downscale or upscale it. Work with the contrast, work with the rotation if the image was skewed to a wrong side. That can affect the result greatly. Also, it's important to understand that the high resolution does not equals a good OCR result, as it basically means that OCR will need to work with a bigger amount of pixels. And first of all, it will increase the time of the processing, because again, bigger amount of pixels, and those pixels may include unnecessary noise that will affect the final result. So at this point, you usually, or the tool you're using, will choose the middle ground that will in the end will produce the best result possible. And okay, after the image was pre-processed, the system is finally received it, and the first step that it will do, it will look for the sections on the image where text is located, and remove everything else, like images, logos, colorful background, or just noise, like unrelated objects on the picture. We don't care about anything else, just the text. the technology or OCR, the scanner, will detect those sections and highlight them. So the next step, which is text recognition, can start working with them and recognize each character one by one. And about that text recognition, like I said, it starts recognizing actually those characters, and based on the visual patterns, it will guess which character it is most likely is. It will never know for certain, so you will never get a 100% result, but based on the patterns, it will make a guess, and as the end result, you will receive the text. And after all the text elements is recognized, the final step is verifying the accuracy. The text is cleaned, validated, refined in some cases, and we receive, with the result, we also receive so-called confidence score. It is basically a percentage how confident the OCR scanner is about the text it scanned. So we are aiming for results around 80%. It means that the scanned text is more or less reliable. And I also wanted to highlight two of the steps separately, as they are much more complicated than the other one. And honestly, if there is someone has time or just wants to, they can create a separate presentation about them, as they include a lot of pretty interesting info and text detection and text recognition. That's what I'm talking about. Like I mentioned in the previous slide, the text detection detects the areas. It does it by the first of all the contrast, as usually text stands out from the background. If you're talking about the regular classic text, black text on the white background, if it's a document or a book, or if we, as an example, we can see a white text on the brownish background or whatever. It's also a good example of how real or seen images are harder for OCR to analyze, as the surface is it's pretty problematic. We have a reflection. The color is like the contrast is not the best, but still it managed to recognize most of the characters. I can only see that one letter E was not recognized, but overall I think it's a pretty good result. Repeating shapes, letters or numbers or just characters have the same shapes, and if we can see that those shapes are repeating, that's a good indicator that we are looking at area of text. Alignment patterns as well. Text is usually aligned in straight lines, at least, usually. There can be standalone words, but still they are not a single characters, and OCR still can handle it as text. Then text recognition, the step where the system uses the learned visual patterns to recognize the characters. It looks at the pixels and at their alignment and at their shapes, and make a sort of guess. Even it doesn't sound reliable, but let be educated guess about which character it is looking at. And at the end, it gathers everything together and provide us with the final result together with the confidence score. Now, a little bit about the different types of environment where we can use the OCR. I highlighted 3 of them, 3 main types of environment. The first one is client-side. As from the name of it, you can guess that it's executed directly in the browser. There are not many examples of such tools, but still they exist, and to this day they are relatively popular. The biggest advantage of it is relatively lightweight. It's quick, so you get almost an instant feedback, and it works offline. You can scan images even without internet connection. The trade-offs, as you are using client-side, meaning the client's browser, the performance is unpredictable, and if the user is scanning something on mobile device or older device, there can be unpredictable performance issues, especially if the image that he or she are scanning is complicated with a lot of text, or if the image is heavy and not optimized before the scanning. The second group is server-side or self-hosted. Those type of tools are still inside your own architecture, so nothing is exposed. Like I forgot to mention, one of the biggest advantage of client-side as well is the privacy. That means when you are working with the sensitive data, when you're scanning something that should not be exposed to the third party, client-side and server-side that are locally hosted are the best solutions, because nothing leaves your environment. So back to the server side. At this point, you have full control over the performance, because the scanner will always be using the hardware of the machine it is hosted on, so there won't be any unpredictable performance issues. Also, the models that can be hosted on your server side are much more advanced and provide much better results than the client side. And no vendor lock-ins, again, no browser limitation, because everything runs on the server. As for the problems or trade-offs, it's our infrastructure cost, or increase of the infrastructure cost, because most likely you'll need a separate environment to host such OCR tool. You wouldn't like to host it together with the application itself, as it would add unnecessary limitations and performance issues. Well, and scaling and maintenance, that basically means you just need to do much more work than just adding the client side. And you will need to maintain and scale it and build it almost from the scratch. And the third group, probably the easiest approach, is Cloud API. Those services are already handled all the heavy lifting for you. So what's required from you, it's basically just provide an image, configure the service you want to work with and receive the results, and then do whatever you need to do with that result. Again, like I said, almost all the work is handled for you, but of course, such services are not free. I'm not sure if there is any type of free API OCR service. Maybe there is. I don't know, but you'll need to do a pretty deep research for that, but the most popular are not. Also, privacy concerns. Of course, at this point, you're sending image to the third party, and if you don't want the data you are scanning to leave your infrastructure, that's probably not the best solution. And a little bit more about the tools to those groups. And the first one, client side. There are not much examples here. The widely used Tesseract.js, that is basically a front-end wrapper for a native Tesseract engine. And OCR.js, much smaller tool, not widely used, and maybe just for the demos or some extremely lightweight scanning. So if we're talking about client side, the Tesseract is the one to go. The server side tools, excluding all different models, MTLs, and so on, there are ready services, Paddle OCR and Easy OCR, the most popular ones. Also, you can host a native Tesseract engine, not the wrapper, not the Tesseract.js wrapper, but the native one, as a service as well. Also, next to the cloud API examples, the most popular ones are Google Cloud Vision, Avast, Extract, Azure, and OCR Space. Like I mentioned in the previous slide, those ones are not free. A little bit about pricings. I'm not sure about all of them, but definitely Google Cloud and the Amazon one, the AVS Extract, provide a trial period, which is based on the amount of scans you made. So the price is pay per scan, and I think the first 1,000 of scans per month are free, and after that you will start paying for each scan individually. And about the price, I think it's around $1.50 for 1,000 scan. The price you will pay, and they are also have the system that the bigger amount of scans you will do per month, the lesser price will get. So after certain point, I don't remember it exactly, I think 1 million scans or something, the price will reduce. Okay, now the biggest limitations of OCR. The most obvious one is, of course, the quality of the image, the overall quality, the blur, the lighting, if the image is skewed, or if the photo is taken in the weird perspective. Obviously, the scanning will struggle. It doesn't matter how powerful is the model or the tool you are using. The worse quality of the image, the worse result you will receive. The more advanced tools, they have smarter pre-processing, the first step I mentioned on the second slide, that can reduce the noise, that can increase the quality and consequentially will increase the quality of the text you will receive. But that's not all. Even if the image is perfect, but let's say font on the image is hard for OCR to read, it can still struggle, it can make mistakes. For example, if letters are pretty similar to numbers, OCR can easily start to mistake them, and well, like I don't know, the best example is probably letter O with the 0, and if it is, especially if it's a classical OCR that doesn't understand context and cannot fix that mistake based on the previous text or overall meaning of the text. If it's just analyzing characters one by one, it can easily make mistakes, or if the font is even more unreadable, it can just refuse to read anything and will return you almost nothing. Complex layouts, again, a big pain for classical OCR that does not understand context and tries to read characters and text as it is, based on the hard-coded rules. A good example is columns. OCR reads text in lines, and when you have a table, for example, table has headings, and underneath those headings there is a text. OCR will not understand that the text belongs to the headings. It will just scan everything in lines and mix up the values, which can create problems if you need if the text if you need to do something with the text, if your work does not end on just scanning, if you need to retrieve some values, for example, then it can make it much more problematic, because the text gets messy, everything is mixed up, and yeah, you will need to add some additional logic to resolve such issues. Colored backgrounds or colored pages, that is more about the contrast, and well, that makes sense even in the for just human eye. When there is not enough contrast on the page, it's harder to read. It doesn't. OCR is just the same. If the text is poorly visible because the contrast is not good enough, it will fail to read it. Special characters and symbol limitation, that is also more to the classical OCR, that does not involve any type of artificial intelligence that helps to understand the characters. So yeah, if different types of those characters were not added to the recognizable patterns for the OCR model, it will just fail to read it, or starts to hallucinating and mixing it with some other characters that are look-alike. Accuracy conversion, like I said, the results are more probabilistic, as you will never receive a 100% certainty from the OCR, because it doesn't exactly know the character it's looking at. It makes a guess based on a lot of factors I already mentioned multiple times. So even when the accuracy score or confidence score is high enough, you cannot be 100% certain that everything was retrieved correctly. Now, a little mention for the client-side tool that I have experience with. and I already mentioned it, it's Tesseract.js, which is a library that brings the Tesseract OCR engine to web application. It was built with the help of WebAssembly and the tool to go if you want to implement not too complicated OCR in your web app. It's free. It's also open source, and it's been for a very long time. Like I said, runs locally, doesn't require any third-party services. Pretty easy in implementation. The config is not too big, easy to start, and from that point, you'll just add whatever logic you need after you receive the text that it provides as a result. Yeah, no license fees, no usage limits. Results are fast, depending on the type of image you want to scan and your device, more or less. And they are consistent. So if using the same config, doesn't matter how many times you run it, it will always return the same results. That's in comparison to the, let's say, AI-driven OCR system that will, like any other AI, it will give you not dramatically, but still different results. That can make the debugging process a little bit harder. And yeah, no quotas, no external dependencies. It's completely free. As an example, I added just a simple photo of a child's book, English, from England. Unfortunately, I cannot provide real examples from our project because it contains a lot of sensitive data that cannot be shared, and that also was one of the reasons the client-side solution was implemented. The image is not too complicated, just a couple of paragraphs of text on the books page, so the contrast is also pretty good, but even though it still provided pretty good results, and it takes around 1 second for the scanner to complete it. So overall, I think not that bad for a simple client-side OCR tool. And I mentioned it multiple times throughout the whole presentation. The AI, of course, it's like in any other technology, it is widely used, and in OCR, it makes perfect sense to use it. It makes results much more reliable and better. And yeah, and it just makes sense to apply it, and most of the modern tools are widely using it, and it greatly helps with the stuff like handwritten text. It provides better results because it understands context. It doesn't rely on just rule-based patterns. It can fix mistakes for the difficult fonts because it understands the context and what the text is about. The one big advantage is, of course, language aware post-processing, because in the classic OCR, the language needs to be separately added to the library. If it does not work with the Spanish language, you will never recognize the Spanish language on the image you try to scan. And with the AI based, of course, it's always language aware. And semantic understanding, field meaning, not just characters. The the stuff I already mentioned multiple times. It works much better with complicated layouts and complicated text. As for the disadvantages, there are not a lot of them. The ones I highlighted is computational cost, meaning that you can host a model on your server, but you'll need to spend something on that server. That's the cost. Or you can use a API solution, but then you will pay for that solution for each scan after a certain point. It takes more time than the client side, because especially on the larger images, you win in the quality of the scan, but yeah, you will pay something in the processing time. Less predictable output, like I mentioned, like in any other AI solution, the results can be different, maybe not that much, but still they are not the same, and usually requires cloud services or heavier infrastructure. That by itself is not that big of a deal, but in comparison with the classical or client-side OCR, we can count it as a trade-off. And I think that's all. Thank you very much for your attention and your time. If you have any questions, feel free to ask them.